Hello, everybody. My name is Aniket, and today I'm going to explain the topic of friction. Friction is one of the most important forces. If we look into the industry, most of the losses are due to the frictional force. Friction is a force acting between uh, two surfaces in contact. So, the friction is such a force which opposes the relative motion between the two bodies. So, mm, for example, if this is a rough surface, a box is placed on it, and if we apply a force F, the block does not move easily. We see that we have to apply a uh, continuously increasing force in order to get the block in motion. We see that there is a force in play which acts in the opposite direction uh, to the applied force. And this is called the frictional force. Now, frictional force can be divided into two types. There's also a third type called rolling friction. But today we'll see only static and kinetic friction. So we have static friction and kinetic friction. The formula for this is Fs, which is the static frictional force, is given by mu s n, and Fk, kinetic frictional force, is given by mu k n, where mu s stands for coefficient of static friction, and mu k stands for coefficient of kinetic friction. Now let us see. Uh, Consider again this flat surface. It is a rough surface, so there is a box resting on it. Now we apply a particular amount of force. We see that the block does not move. So there is a frictional force opposing it. This frictional force is acted by the surface onto the body. Suppose we call this block as A and this surface as B. So we can call this uh, this frictional force actually acts on the body. The frictional force acts on the body, and this is frictional force uh, on A due to B. And as you know, due to Newton's third law, same equal and opposite force is applied by the body on the surface. We are not concerned about this now. Uh, so the FAB. So initially, when you apply uh, when you apply a little amount of force, say capital F, this is varying. So you get an opposing force, small f. You increase the capital F, still, uh, still the frictional force increases. Again, you increase the capital F force, still the block does not move. There's still more frictional force. So one point comes where the frictional force, small f, static, is overcome. There you observe that the box starts moving. So we know that until and unless the capital F is less than Fs, that is mu s n, where normal reaction acts in the upward direction. So until the capital F is less than mu s n, the box won't move. The moment it becomes equal mu s n, excuse me, the box has a tendency to move. It will just start moving. So we can observe relative motion once the force becomes greater than mu s n. Okay. Mm. Then you can observe the kinetic friction coming into action. So in kinetic friction, just to say in short, the box is in motion by the application of the force capital F. That is a frictional force acting given by mu k n. So the acceleration, since the box is in motion, there is some acceleration because the acceleration can be calculated by the net force capital F minus small f divided by the mass of the box. And mu k is mostly determined uh, experimentally. In questions, it would be provided. Uh, on the other hand, mu s is a uh, is concerned with the static uh, case. Okay, so next we will see for the students of 11th, 12th, I think since immediately after 10th, uh, after they leave the school, their mind is like free. They want to learn more. They are highly curious. And what happens due to this system of education which we are following, we tend to kill their curiosity. And this is what I relate to myself also. Because students are interested in knowing what really is happening rather than just the formulas and solving the numericals. That anybody, any logical human being can do it once you like practice enough numericals. But they are more concerned with how to like how the thing or the concept is actually working. So we we as teachers should provide them at least an idea what is going around and tell them to come back to the formulas in order to clear the exams. Because once you clear the exams, then you are free to research and find out what really goes on. Because this is not an easy thing. People have spent their life to come up with these formulas, with these theories. So it cannot be understood so easily what really goes on inside. So, for example, let us see. Uh, this is the rough surface, and imagine this is a wheel of a car moving. So we know that friction aids the motion. I can say friction aids the motion of the wheel because if friction wasn't there, the wheel would have just spun in this direction. The wheel would have just kept spinning and spinning and spinning. It wouldn't have moved ahead. So if we take a microscopic image of this section, this is the road. This is the the wheel. So imagine a wheel is climbing up a mountain. So as we climb up the mountain with our hands and with our legs, imagine this that the wheel is climbing up a mountain. Only because the rough surfaces exist, the wheel is able to move ahead on the road. So this is what actually provides the frictional force. So you can make an analogy of climbing up a mountain. So if friction wasn't there, the wheel wouldn't have moved ahead. Same goes with us walking on a road. If friction wasn't there, we wouldn't be able to walk ahead. Okay, then we can ponder on this more, the interested students, and the depth of this you can get to learn once you start research. For the exam point of view, We will just understand the concept and we'll apply the formulas. So let us see an example. So let us imagine a disk rotating. So imagine a block kept at a radius, at a distance r. The radius of the disk is capital R. So imagine this wheel rotating with angular velocity omega. Here you need some context of circular motion and centripetal forces. Those formulas I will give you. Here the question is the angular velocity is omega and it is increased to omega dash. So what is the tendency or which direction would the box slip away? Would it be tangential, would it be radial or any other direction? Many options would be given. So let us see. Initially, when the disk is rotating, the the box the speed is the angular velocity omega is such that the box does not fall off. So we can say that the friction is aiding the box and it is taking it into the circular motion. So the frictional force is acting between the box surface and the disk. This is actually the top view we are seeing. So the frictional force will aid the circular motion. So the box is going into circular motion, and that is the centripetal force, which can be given by mr omega square. It acts in the radial direction. This centripetal force is actually the frictional force given by mu s normal reaction. Here the normal reaction can be taken as mg. So when we equate them both, so angular velocity turns out to be square root of mu g by r. So this is the angular velocity which you do not have to exceed in order to avoid the block from slipping. So uh, once you increase the omega to omega dash, there will there will be a tangential force acting on the block. Uh, so since the direction of omega is in this direction, so tangential acceleration would also be this direction, at. This tangential acceleration at is given by r alpha. Alpha is the angular acceleration. Angular acceleration. So again, if we draw the diagram, so here we have centripetal force, that is the frictional force in this direction, and we have the tangential acceleration in this direction. Now, this tangential acceleration, this force is provided by the disk to the block. So, so net resultant force would be acting in this direction. F resultant. So this is actually the net frictional force acting on the box after increasing the angular velocity. So since the frictional force acts in this direction, the slipping tendency would be opposite to the frictional force, resultant frictional force. So this is actually the direction of slipping relative to the disk. Slipping of box relative to the disk. So this might seem a bit counterintuitive, but many people would have thought that it would be completely tangential, but this is how physics reveals itself. This is the tendency of slipping. So the frictional force acts in the opposite direction. Okay, thank you so much.